Dr. Peterson, this is Caitlin. I'm doing the redemption project for the square root curve. I'm not gonna lie, this is like the 8th time I've filmed this because every time I mess up. Sorry. So, here we go. My real life example, I chose a knight who's defending his castle from an attacker, and he's swinging around this maze to defend himself. Basically this is all physics and the centripetal acceleration of a rotation of an object. So like this is going to be, whoops, mess up, but I don't care. It's going to be accelerating like this and moving like this. What is a centripetal force? Basically it's just the force that pulls on an object that's in rotation, in a motion of rotation basically. So basically here I have a satellite with a kind of like a pattern of rotation around the Earth. So if this is rotating, what's keeping it from going out into space absolutely nowhere? We have the centripetal acceleration, which is what we're going to be solving for in our problem with the knight. Over here, it's basically just linear speed over radius. So if we have a linear speed of 13 meters over seconds over a radius of 2, we're going to plug that into the formula here. So we're going to square 13 and divide it by 2. It's going to come out to 84.5 meters per second squared. But the notation you really should be using is, in fact, newtons. Alright, centripetal acceleration can increase or decrease, but how and by what factors? Basically, let's just say that all the velocities in this example here are equal, but the radius or radii, I don't know, I'm sorry. It's going to differ. So we have a 2, a 4, and a 6 centimeter radius. If we think back in terms of the equation we use here, we're going to want the one that divides by the least to give you the greater magnitude of the acceleration later. So we're going to use a 2 instead of the 4 or the 6 because it's going to end up giving you a larger number for the acceleration. So the correct answer is A. So if you can already see my circles, like I said, I've already filmed this like 6 times. Now we're going to say that the radii are equal here, but the linear speeds have changed. So here we have an original speed, twice the amount of that original speed, and half the amount. We're going to want the one, again, that gives us the greater amount, or the larger number, toward the end of the equation. So if this is original, yeah, that's cool. It's pretty good. But if we decrease it by half, it's really going to give us less of an answer. But if we increase it by, like if we double it, it's going to give us a larger number to divide by, in turn giving us a larger acceleration. So we're going to use B and not A. And that is the correct answer. So I hope I get the square root curve, and I hope this informs somebody who's confused about this. And thank you for watching this on this fine Sunday. Bye.